Hello everyone, I am Rais Ahmad and today I will present the development of a drone-based thin-film solid-phase micro-extraction water sampler to facilitate on-site screening of the environmental pollutants. The contents of my presentation are the introduction, experiments, results and discussion and conclusion. In the introduction part, we will discuss some new things and we will discuss the aims and objectives of this work. First of all, what is thin film solid phase micro extraction? So it is actually the extended form of the solid phase micro extraction. In this, the extraction phase is coated with a thin planar sheet, and it is characterized by possessing a greater surface area. Thus, it provides a higher extraction kinetics, though it results in a lower detection limit with the short sampling times. The hydrophilic lipophilic valence particles and the polydimethylsiloxane were used as a coating on the carbon mesh support, and the advantage of the HLB PDMS or the hydrophilic lipophilic valence PDMS is that it is polydivinylbenzene co-in vinyl pyrrolidine skeleton structure, so it provides a balance of the hydrophobic and hydrophilic intermolecular interaction, and therefore it is useful for the broad polarity and untargeted analysis of the environmental contamination in water. The oil and gas process waters and tailing ponds are rather very dangerous to access. So typically it requires the specialized training, and it requires the PPE or the personal protective equipments and certificate to the sample. For this purpose, the scientists use the unmanned aerial vehicles for the sampling, but usually the vehicles or the drone vehicles were used a very high quality with a price of about 10,000 US dollars. So in this experiment, they use the lighter unmanned aerial vehicles for our drone based thin film solid phase micro extraction that is coupled with the hydrophilic lipophilic valence PDMS that is used to remotely screen the pollutants. The hand portable GCMS instrumentation is used for the on-site analysis, and the benchtop GCMS is used for the in-lab analysis for the comparative study. These are the two instruments which is used. The benchtop GCMS is used for the in-lab analysis, and portable GCMS is used on-site for on-site analysis. The design of the thin film solid phase micro extraction equipped with a drone water sampler is shown in the figures. Here the polystyrene were connected to the lower part of the drone so that the drone can float on the surface of water. There is a fishing line in the PTFE tubing. To one side of the fishing fluorocarbon fishing line there is a floater, and to that floater the fishing swivel is connected, and that fishing swivel is connected to a bell sinker. This bell sinker is made up of the lead, and its weight is 3.5 gram. To other side of the fishing line there's two splint cotter pin, and these splint cotter pin were made up of the stainless steel. Between these two split cotter pin there was a thin film solid phase micro extraction. So, and to this side there is a lead bullet sinker was connected, and its weight was 1.75 gram. When it is lifted off for the flight, so this part comes down because it is a heavy part, and this part go inside the PTFE tubing shown in the figure in here. So the purpose of this is to protect it from the environmental contamination and during the flight. And after when it reaches to the surface of the water, this part become floating on the surface of the water, and this part goes down for the sampling. Various experiments were conducted in this method to evaluate the effectiveness of this method. Handling blanks were run in the lab to prove that the membrane was sealed from the atmospheric contamination, and to prove that moving the membrane in and out of the PTFE tubing would not add significantly to the potential background. So to perform this comparison, the following TF SPME test sample were performed. Two membrane were used as a blank with no handling, and it is taken as a reference. Four membranes with normal in-lab handling were taken, and four membranes that had been sealed in a different drone sampler that were hung outside for 15 minutes, and the two more membranes that were used in 2 ml glass auto sampler unsealed vials and left outside for 15 minutes. To perform the real on-site analysis of the surface water, it was important to first validate that the drone-based SPME sampler would mechanically operate as designed when it is attached to the drone. So with this keeping in mind, it was decided that the drone would first be tested in a private hot tub, as it would be easy to observe if the membrane would deploy, or it will retract the expected. It will, yes, okay, it will repeat as expected for the method. So for this purpose, the McReynolds standard mixture was chosen, as each of the McReynolds constituents represent a different intermolecular interaction in the extraction processes. To determine whether the thin film solid phase micro extraction drone enable water sampler would properly function for the real drone deployment, a trial run was performed on the surface of the hot water tub. So for this purpose, the two membranes were equipped on the drone sampler, and the drone sampler was then lifted off from the piece of clean aluminum foil. So when it reached to the surface of the water, it automatically the sampling part goes down inside the water, and then the drone was then allowed to sit on the surface of water for 10 minutes for sampling. Following after the drone sampling the hot tub water, the real on-site thin film solid phase micro extractions were performed from a suspected landfill. For this purpose, a landfill suspected area was selected, and this site consisted of a small stream that ran from the municipal landfill to the highway. The name of the highway was the Ontario Highway, and then further it goes to the small back road where the sampling was conducted. The one 4 centimeter and one 2 centimeter membranes were attached to the drone during the sampling. This is allowed for immediate on-site analysis, and for the in-lab analysis. For the immediate on-site analysis, they use the portable GCMS instrumentation, and for the in-lab analysis, they use the benchtop instrumentation when it was returned to the lab. The sample for the lab was stored in a TD tube, and it was transported to the lab in styrofoam container with dry ice in approximately 3 hours. The temperature of the atmosphere at that time was -4 degrees C, and the water temperature was 1 degree C. There was a thin layer on the surface of the water. Okay, in the figure here, it is the chromatogram is shown in the figure A, and it is consisting of a known PDMS background and a minor DVB background, and both of them are known to come from the membrane themselves. So there was no observable difference between the blank desorption of unused membrane and those of the given normal handling, and the membrane placed into the drone samples for 10 minutes and hung outside, and the other membrane that is placed in the 2 ml glass vials for 10 minutes. So it indicates that the samplers were not at the risk of being contaminated from the atmosphere when they were placed on the drone for flight. In the figure B, we can see here that these sealed tests indicated the negligible depletion of the macronold standard after being sealed in a drone sampler at room temperature. There was no noticeable loss of the analyte from the membrane that are sealed in the TD tubes and on dry ice. Hence, we can say that it is proved that the drone sampler is capable of preventing the sample loss, and the most importantly, it prevent the benzene, which is the most volatile compound. So it did not deplete during the various tests. In terms of the analytical performance, the percent relative standard deviation for the 6 chlorination byproducts were identified, and the result was quite reasonable. It is ranging from 5% for the 1,1,1 trichloro 2-propanone and 16% for the benzyl nitrile, and given in the table. Here, after performing the hot tub experiment, the on-site analysis were performed. The on-site analysis were performed, and as it was expected that it was expected that it will have a high level of phthalates, polychlorobiphenyl, and polycyclic aromatic hydrocarbons, and some other compounds that is normally the indicative of the landfills. Some other small amounts near the limit of detection of high level phthalates were observed instead of that. So instead of that, and some various alkyl benzenes were also identified. It is important to note that many alkyl benzene compounds have very similar spectra, and these the peak heights of these ratios generated using the portable GCMS, which was this is because the similar peak height, and the peak height was because of they used the novel toroidal ion trap mass analyzer and an N-trap 70 electron volt and electron ionization source. So it differs slightly from the benchtop single quadrupole instrument that is normally used for the NIST spectra. But even though the result was more than match criteria was more than 50%, so it is quite reasonable results. The most importantly it should be noted that several other several other high levels of styrene and 1,3,5 trichlorobenzene and propyl benzene that its high level indicates that these are the contamination that is originating from the internal combustion of the hydrocarbon, such as the diesel and gasoline, because the proximity of the highway to the sample water course gives a probable source of this contamination. So this is the fact that all these compounds could immediately identified and using the on-site GCMS instrumentation after the thin film solid phase micro extraction sampling. So it is a good indicator for the potential impact of this method. Here we can see that the quick on-site screening was successfully demonstrated in this method, and there are some other volatile alkyl benzene were also extracted and stored in this method, and they were also stabilized for the on-site analysis and lab analysis. But there are some drawbacks for this method. The winter conditions were not favorable for this method because it resulted in the depletion of the drone battery, and the extraction of the some semi-volatile compounds were kinetically very slow because of that winter conditions. So this is not a favorable condition for this method, and moreover this method is also not good for the fast flowing water like rivers. It is usually good for the ponds and lakes. In conclusion, we have seen that we presented the low cost drone based thin film solid phase micro extraction water sampling device, and it is protected from the sample it protected the sample from outside atmospheric contamination for at least 10 minutes flight time. It also stored the volatile compound such as the benzene, and it also determined the disinfectant byproducts from the hot tub, and this shows the very usefulness of this for real water samples. This was also confirmed with the in-field use of the drone-based thin film solid phase micro extraction when combined with the portable GCMS, and those on-site results were reported by analyzing the collected samples in lab with the benchtop GCMS instrumentation. Thank you.